Hello.
Good morning, Mr. Tyagarajan.
Morning,
AV,
sir. Good
how
morning
are
very
you?
much. Fine, sir. Fine, sir. I
Excellent.
hope you are also having a good day.
Yeah, thank you and wish you the same.
Thank
Uh,
you, sir.
Now, we are going to help many people
Okay, sir.
based on your good work done yesterday on the SPC, Statistical Process Control.
Sure, sir.
Uh,
Sure.
I just want to give a very brief introduction about Mr. Tyagarajan. Tyagarajan is a very interesting personality. Predominantly, Tyagarajan worked in Malaysia close to 10 years. He is also a product of Lucas TVS, Chennai division. Now, Tyagarajan is back to Mother India. He lives in Chennai. Am I right, Tyagarajan?
Yes, sir. Yes, sir.
Mr. Tyagarajan has undergone a recorded video program on statistical process control (SPC) this month. And Tyagu, thanks for connecting. How do you find this particular program on SPC?
Actually, I have already taken the APQP course from
Yeah,
Padhmam Consultancy, sir.
yeah,
So that was very good and effective as well.
excellent. Thank you.
So with that, I wish to proceed for other core tools as well.
Yes, a great idea.
Yes, sir. So based on that only, I took the SPC. So
Yeah,
next, I'm planning to take MSA also.
excellent, excellent. Thank you. So, how do you find SPC program, Tyagu?
Actually, the course exceeded my expectations, sir.
Oh,
The
thank you.
curriculum was very comprehensive, covering
Okay,
all the statistical control techniques,
okay,
which are essential for monitoring and improving process quality.
excellent.
And sir, your explanations on control charts regarding the process capability,
Yeah.
as well as the homogenization, were very practical and very much easy to understand also.
Okay, okay, okay. Uh,
Oh, yes,
Theo,
sir.
I just want to intervene. Generally, there is a belief that
Okay.
if it is a virtual program, it won't be effective at all.
No, sir, actually, the myth was busted here.
Okay.
Because especially the standard deviation calculations through both the RMS and range methods made the complex steps also much more accessible and very easy to
Excellent.
understand.
Excellent.
Uh, as per me, overall, the course is highly recommended for anyone serious about quality control and process improvement.
Yeah, yeah, yeah. Absolutely.
So, thank you so much, sir. Thank you so much
Excellent,
for your
excellent,
effort and designing such a fantastic course.
excellent. We are all in the business and then we should justify. Okay. Good.
Of course, sir. I agree.
Tyagarajan interestingly has done a very good exercise based on the workbook during the course. I just want to, project that. Thiago, my screen is very much visible, right?
Yes, sir.
This is on some process called, bagged chemical. Okay, doesn't matter. And the good thing is that, every details, minute details are also mentioned in the Excel. Okay, machine details, gauge details, spot number, so on. Okay. So please see, Thiago, I really appreciate for the great work done by you. Even you are so meticulous in mentioning even the page numbers also. Tomorrow, if someone takes our course also, okay, they can easily relate.
Actually, I did it for my reference. It will
Yeah.
be very easy for me to refer.
So it's going to be a reference for many people from now. So no more your property. It is everybody's property, the
No
work.
problem, sir. No problem.
I like the spirit. Thiago, you have done it so nicely. Some average of X, that is X bar, range or, okay.
Yes, sir.
I just want to raise few queries to you. Okay.
Okay,
What do you
sir.
mean by sample size 5? N is equal to 5, you mentioned.
Yes, sir.
What do you mean by that?
So the sample size which we collect periodically based on the time. So
Yeah.
at 9:30 we are collecting 5 pieces.
One,
At
two, three, four, five, five data
yes,
points.
sir. At 10:50
10:50
again
again.
we are collecting
Fantastic.
five
Fantastic.
pieces.
Fantastic. Excellent.
So these are called the samples and
Yes.
especially
You
the
can
small
call this
n.
as subgroup size also. I just want
Yes.
to know, document here. Subgroup size is 5. What do you mean by M, small m? You mentioned
Which is
as
called a subgroup, sir. Which
uh,
means in how many intervals we are collecting.
excellent, excellent, excellent.
So
Totally, how
total
many?
we have 24
Yeah,
intervals.
you have mentioned as 24. Yeah,
Yes, sir.
this is the count 24.
Yes, sir.
Okay. So 5, 5, 5, 5, 5, like that. 1, 2, 3, 4, 5, 6, 7, 8, like that.
Yes.
24. Uh, Thiago, do you have any acceptance criteria for small m? That is number of subgroups. We can call this as number of subgroup also. Number of subgroups.
Subgroups.
In any number you have?
Minimum 21, sir.
Excellent. Minimum 21 for
Subgroups.
all SPC purpose.
All is okay,
Most
sir.
of
Okay.
SPC purposes.
Okay, sir.
Okay. Then sum of x bar. Can you just explain this?
The sum of x bar is after summing all these five samples, we are getting 113 here. So similarly, we need to calculate all these samples,
Plus.
and then again we need to sum all these sizes. Yeah. Uh,
Okay. Rather, you may explain on X double bar that will add more value to our people.
okay, sir. So after
How
adding
do you
all
get
these,
this 517? I just want to know. I'm just wondering. C13 to Z13. Oh, okay, okay. This is sum of X bar. Okay.
x bar,
Understood. This is this sum of all X.
all x,
Okay, this is X bar sum. Perfect. So 517 comes from
after adding this at
22.7,
22.7, 22.2,
22.2 plus
22.4, all
22.
these.
Paka, paka, paka.
Yes, sir. And these 22.7 and 22.2 and all the average of these samples,
Yeah. Average of individual subgroups,
individual samples. Yes.
subgroups. Okay.
Yes.
Then you are getting X double bar, right?
Yes, yes, sir.
Okay. Then similarly, you have done it nicely, sum of all ranges. That means all ranges, right?
Yes.
0.5 plus 2.5 plus 1.5 plus 2 plus 2.5.
Yes, sir. After adding all these things, all these range values, we will get 65.
Yeah. Why do you want that addition of sum of all ranges? It is to
Yes,
get
we need to consider all the subgroups,
ranges of the groups.
ranges of subgroups. Yes.
Then this is R bar, correct?
Yes, sir.
Okay. So it is to hint our learners. Okay, this number and this number are essential.
Yes, sir.
Okay, important outputs from any control chart for the reason. Any control charts. What is the sigma cap?
Standard deviations.
Sample
Standard deviation
standard.
of samples.
Sample standard deviation. You
Yeah,
can call this as
sample
S
standard deviation.
also.
Yes.
Sigma cap. Okay, sigma cap. How do you get this 1.2? You have beautifully created macros also. I enjoyed. You could see
Thank
here.
you, sir. Thank you, sir. So
So,
actually, to calculate the sigma cap, we have two methods. One is RMS method, and another one is the range method. In
excellent.
these, I follow the range method.
Super. Since we have organized data, okay, no harm in falling in line with the range method.
Range
R
method.
bar by D2.
D2.
D2 is from where?
D2 is constant.
Constant. From the
Small
constant
d2.
table. Yeah.
Yes.
Fine. So you got a number of 1.2.
Yes.
I have a question to ask you, Thiago. This number, smaller is better or larger is better?
Well, we cannot say exactly, sir. Yes, it depends upon the product and the data we collect, the
Okay.
specification limit, everything goes in well.
I agree.
Yes,
Not really connected to spec limit because these are all from the actuals. Okay.
Yes, sir.
I get another number, 2.5, example.
Yes.
Which is better? 2.5 is a better number or 1.2 is a better number?
Maybe if the specification limit is wider for a 2.5,
Ah,
then 2 point will be better.
excellent. So generally 1.2. Smaller is
Generally 1 point. Yes, sir.
okay.
Actually, it
Smaller
depends
means
upon the
what?
specification limit again.
The variations are less.
Less.
Correct?
Yes, sir. In
Right.
case the tolerance is very tight, then 1.2 would be the
Yeah,
worst
yeah,
case, then
absolutely.
2.5 is
Absolutely.
better.
Generally smaller is better.
Yes, sir.
You are now linking with the capabilities. Okay.
Okay, sir. Okay.
So Chabu has taken A2, D3, D4, all from the tables. These are
Yes.
all from the
Constants.
constant table.
Tables.
Constants table. Okay. Statistical constants table. It is to educate our learners.
No.
Right. You explain now, or if you have any questions, also you may ask me.
Maybe I'll try to explain, sir. If there is any mistake, please correct me.
Yeah, sure. I'm here.
So after finding out all these values, then I calculated the upper control limit and lower control limit.
Super.
Here I got 23.1 as UCL and 20.0 as LCL.
For X
So
bar.
yes, sir, for a X bar. And
X
then
bar.
for R chart, I get 5.7 and 0.00. So first I need to compare the R bar values with these range values.
Excellent. Excellent. Not R bar.
I
You
mean
can
R value,
rather say, upper control limit. 5
upper
points.
control limit.
5
R
points
chart
you
control
take
limits,
directly,
UCL.
or you must do something else.
No, 5.7. Then,
5 points only. Absolutely.
yes, 5.7. Directly, I need to compare with the range values.
Super.
So here, if there is any value which is greater than 5.7,
I
then
just put a
the
switch.
range
Yeah.
is out of spec. I mean,
Not
the point
spec,
is
control
going.
limit. Any
Yeah,
control
yeah,
limit.
out of control limit. Yeah.
Yeah.
Sorry. So here we have two values, which is 6.5 and 7.0. Both are greater than 5.7.
That means there is
The
an
which is,
assignable cause.
yes, sir.
Clear, na? There is
Yes,
an assignable cause.
cos.
Tiago, I have a question now to intervene.
Okay.
If range is more, that is more than 5.7,
Okay, sir.
what is the meaning? Statistically,
Uh, out of control limits.
agreed. You can
Special case
rather
is
special cause, I agree.
then
Rather, you
yes.
may say the spread is more,
Yes, sir. The spread is more.
not precise.
Okay.
Clear?
Okay, sir. Okay.
They are not precise. Okay.
Okay, sir.
So for homogenization, you
Mhm.
have removed 7.0 and 6.5.
6.5.
Beautiful. Corresponding X bar also to be removed.
Yes, sir.
20.7 removed. So
21.3
nicely.
also. Yeah.
21.3. Excellent.
Yes, sir. So after removing these two values, then we have 22 subgroups.
Yeah.
Again, we need
Super.
to do the same calculations, like the average of R bar we need to find out.
Yeah.
So here it is the average of
So
R
I
bar.
just want to know little more, elaborate. So originally M was 24, right?
Yes, sir.
Now two
22.
columns are removed. 24 has become
22.
22. Excellent. Then again you compared, right?
Yes, sir.
Was there anything exceeding?
No.
Excellent. Means now it is a natural lot.
Yes.
After removal, it can be called as a natural lot.
Natural not.
Super. So you
Yes.
have done it so nicely. Yeah, 22 you have mentioned.
Yes, sir.
Some also you mentioned. Excellent. Okay, okay, right. Okay, okay, okay. In my opinion, this is not required. Only one time you may compute the sigma cap.
Okay, sir.
Okay, this is not required.
Okay, sir.
Then, have you done anything regarding homogenization on the X bar side? Range you have done.
Yes, sir.
X bar side, you have removed something
Yes,
here.
sir. X bar also we have to do because already we have skipped two columns. And
Okay.
then we need to compare this UCL and LCL with the average of our X.
Excellent. Excellent.
Yes, sir.
Excellent.
X bar values.
This column is also removed, right?
Yes, sir. So here 24.9, which is greater than 23.1. So we have to remove this column as well.
Okay. Again, let us add little more value to our learners. Okay.
Okay.
When you are removing something in the X bar, what is the meaning? Range means not precise. You
Yes,
are
sir.
removing something in the range, not precise. If you are removing something in X bar, what is the meaning?
Decentered. It's not
Excellent.
accurate.
Excellent. Not accurate.
Yes,
Excellent.
sir.
Accurate. That means process is decentered.
Centered.
Here it is excess variation. This is
Yes.
more of decentering.
Decentered. Which means away from nominal.
Excellent. Oh, that also you mentioned. So 22 after removal of this 24.9 has become 21, right?
21. Yes, sir.
Oh, sir. Then again X bar, I agree. Double bar. Super. So if you have any other questions here, Thiago, you may ask.
So whatever I have done so far, is this correct? Whether my understanding is correct or not, I just want to know.
Perfect, sir. No question of correct or not
Okay,
correct.
sir. Okay.
Perfect.
Okay, sir.
So the best part is that, you have taken a lot of efforts to create, macros everywhere. You could, we all could see here. Okay. The macros everywhere. Okay. That will make the job little more easier. So what is
Thank
this
you.
frozen or bar means?
Frozen arbor means once we fix our UCL for the range, then
Okay.
the arbor which we used to calculate the arbor, R chart UCL
Okay.
will be considered as a frozen arbor.
Okay. So that means, do you mean to say originally the R bar was how much?
2.7.
2.7. I agree with you. I'll just take a little more time to remove. Okay. Then our learners can understand much more easier. Okay. I've done so many things. Fine. So originally the R bar was 2.7. Now the modified is
2.3.
2.3. Fine.
Yes.
Very good. This is fine. Originally the X double bar was, I remove this markings also. Okay. So you are claiming after homogenization, the X double bar is 21.4. What was originally
21.6.
calculated? Correct? This one?
Yes, sir. Yes, sir. 21.6. Yes.
So 21.6, no more valid. So after homogenization, you should be considered as 21.4. Excellent.
Yes.
Any other questions here, Thiago? You done it so nicely. I'm very happy.
Thank you.
So
Thank
much
you so
impressive.
much.
So I made some more value addition.
Okay, sir.
I just tried histogram
Okay, sir.
to ensure whether there is a normality.
Okay.
Normality. Normality can also be called as
Frequency distribution.
stability.
Stability.
Oh. Okay. Generally, stability can be seen through histograms or control charts also. Okay.
Okay, sir.
So please see here. Down, up, down, up, 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 down, 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 down. Okay. So you can consider this as a bell curve.
Okay, sir.
Bell curve is okay, acceptable.
Okay, sir.
Okay.
Okay, sir.
Our learners may be wondering, okay, what is the standard deviation mentioned here as 1.5? Whereas you have done the standard deviation calculated as
1.2.
0.2. Why there is a difference?
Maybe that could be for standard deviation of population standard deviation.
Excellent. No, 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 not that way. Both are sample standard deviations only.
Okay.
You adopted range method,
Okay, sir.
whereas
Oh, that is based on RMS.
Better method is RMS method.
Okay,
So
okay,
this is
sir.
through RMS.
Okay, sir.
Root means square method.
Okay, sir.
Excellent. So mean, I'm just adding a little more value. Mean the Minitab software gives us 21.6. Let's consider 21.6.
Okay, sir.
So what you have done originally? 21.6.
6.
Quickly, it is taking over original. But please see here, the Minitab is not considering the homogenization.
Homogenization.
Okay,
Yes.
whereas you have modified as 21.4. It was
Yes.
originally 21.6.
6.
Okay. No, you have done it as 21.4 after homogenization. Okay. That means you have done it in a more statistical way. Okay.
Okay, okay, sir.
I'm just comparing the sample standard deviation alone.
Okay, sir.
Adding value to our friends, when normality is okay, when you are getting a fair bell curve, we are allowed to estimate the sample standard deviation. One ground rule. Am I
Yes,
communicating
sir.
properly, Jamu?
Yes, sir. Yes, sir.
So we are not allowed to estimate the sample standard deviation. No, unless until we are clear on a fair bell curve. That means normality is okay. Okay. Generally,
Okay.
normality is okay means no significant special causes.
Okay, sir.
Correct?
Only chance causes are.
Generally, absolutely all right. Only chance causes, random causes, constant causes, okay, system causes. Okay.
Okay, sir.
Now, Jabu, I'm just wondering how many columns you have removed for homogenization?
Total 3 columns.
Okay. How many we can remove?
Up to 20%.
Excellent.
Yes.
20% of
Uh, Subgroups.
20% of M's.
Yes. Yeah.
So out of 24, you may remove 24. M is equal to 24. Okay.
Yes, sir.
30%. Excellent.
Yes, sir.
Otherwise, there are too many special causes.
Yes.
There is no need for a control chart at all. First, you should remove all the causes of the causes creating the special causes or excess variations. Okay, or
Okay, sir.
descending.
Okay,
Then
sir.
only we are allowed to go for a control chart.
Yes.
Is clear or should I repeat once again?
Clear, sir. Clear. It's
Clear.
very clear.
So first rule, there should be a fair bell curve. Okay, then we are allowed to go for control chart and also sample standard deviation. Second rule, after homogenization only, the control charts to be plotted, provided if the variations are within 20%. Not exactly variations, number of special causes.
Okay, sir.
Jabu, adding to your work, I also tried, okay, an X bar.
Okay, sir.
Are you able to find any special cause variations here?
Yes, sir. There is one point which is exceeding the limit.
This is assignable cause.
Yes. Which is
Clearly?
24.9. We removed.
Yeah.
Yes. Here, 2 points are exceeding the limits.
So
Again, this is also
this is 7.
symbol of assignable cause.
7, 17, I think it's
22.
22. Okay. 22. 22. Okay. Which columns you removed? I have just, got to check. 7, 17, 24. 22. Sorry. 7, 17, 22. So 1, 2, 3, 4, 5, 6, 7. Please see. 7th you removed, na?
Yes, sir.
There also it is clearly showing. Okay. 7. Okay. I'll take 7. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
Yes,
Remove.
sir. Yes, sir. 17 and 22 we remove.
One more. 17, 22, and
7.
7, 17, 24. No?
Yes, sir.
Please see
7,
here.
17, 22.
This is 17, column 17. This is 22.
22.
Fantastic. Fantastic. So that is also, shown here as, test one failed, in or also failed. Okay.
Yes.
See, 1722. It indicates clearly.
Yes.
So, Thiago, that means you have done a better job than a software. Good.
So which means the Minitype doesn't have this homogenization option.
No, kindly understand. It takes the data and gives you the Explorer.
Okay.
That's the problem with any software for that reason. Okay, Minitab is doing a great job. I'm not saying no.
Yes.
Okay,
Thank you
only
so much.
the engineers and managers should put their brain, okay, to
Mm-hmm.
remove these line items.
Okay, sir.
Okay,
Okay.
then recompute the control limits. Okay, I'm
Okay.
just, since you have asked, it is showing 2.7. Please see here. It's a good question you raised.
Yeah.
2.7. Please see whether it matches with your calculations.
Yes, sir. Again, that is 2 point.
2.7. That means what, sir?
It
Homogenization is
doesn't
not done.
do any homogenization.
We must do.
Yeah.
Okay, from the shop floor, we must do 27. Okay, see the control limits also, same 23.1, 20.
20.
23.1, and this is considered as 20.
20.
Super. Okay, then this is 0 and this is 5.7. Please see
7.
here, compare what you have done 5.7.
5.7.
5.7, that's all, sir. So, what is the net learning out of this homogenization, Thiago?
Um, Sir, it helps to reduce the variations,
I agree.
eliminate the special cost in the lot.
Yeah, absolutely. Absolutely all right. So, we must use only the control limits after
Eliminate.
homogenization.
Yes, sir.
That's why, you have beautifully done frozen R bar you have frozen, and control limits you have frozen, X double bar also you have frozen.
Yes.
All 8 rules are applicable here.
Okay, sir.
Control short 8 rules, I mean. Okay.
Okay, sir.
Any other questions, Thiago?
Apart from this, I have a few more questions, sir. If you
Yeah,
have time, maybe we can go through one by
absolutely
one.
no issue.
Sure. May I share my screen, sir?
Yeah, please. Yeah, you are allowed to share your screen.
Yes. Is it visible, sir?
No, not it. You must go for sharing also.
Share all time.
Just go share screen like we have done earlier.
Now is it visible, sir?
Come, yeah.
Okay, sir.
Oh, you framed the questions so beautifully. Yeah.
Yes.
Can you just read it for the benefit of?
Sure, sir. So the first question is during APQP, after completing phase 3, we will conduct a PPAP studies in phase 4. So at this stage, should SPC studies be conducted before or during PPAP?
Can you just type, sir?
Sorry, sir?
Can you just type? I'm just giving my views. You may type.
Okay.
Yeah, there
Okay,
itself.
sir.
Okay. Generally, MSA during phase 3 before SPC. Generally, yeah. MSA studies
Studies,
during phase 3.
which means we need to use the samples from
Yeah. Pre-launch sample. Yeah, pre-launch
pre-run
samples.
samples.
Yeah,
Yes,
if
sir.
possible. Yeah.
Yes, sir.
Or at least before SPC studies during PPAP run. PPAP generally we don't call as a studies, we call as PPAP run. Yeah. Have I answered the first question of first part of your question?
Yes, sir.
Sample collections.
Yes.
Just type samples. N is equal to small n. N is equal to N is equal to
Yes.
5 and M is equal to 25. Means, within bracket, okay, you can try means also, yeah. 125 consecutive samples. Consecutive samples. 125 consecutive samples. Ideally. Samples, ideally. Ideally, yeah. Super.
Which means
Consecutive
the
is
first
underlined.
125 parts of the PPAP, right, sir?
After the setting approval. You may just put in within bracket after setting approval. After, I literally mean here, after setting approval, collect 125 consecutive samples, breaking them into 5 into 25. That's all.
Okay, sir. So, my question is, the PPAP run will be done after only the setting approval, right?
PPAP run is done after?
Setting approval.
Not that way. During PPAP run, the setting approvals can be given.
Okay, sir.
Then conduct
No,
the
the PPAP samples, the 300 parts will run
300.
only
Absolutely.
after the setting approval, right?
No, 300 means you should produce 300 parts
Okay.
after setting approval.
Yes, sir. That's what I mean.
Absolutely.
Yes,
Absolutely.
sir. So from that 300 parts, the first 125, I can consider it as SPC samples, right?
Ideally, first 125. I agree with you.
Okay, sir.
125 continuous. Yeah.
Here I have another question. If my SPC study fails,
Hmm.
so let's say the same example which we discussed earlier.
Mhm.
So the chart is going out of spec initially,
Out of
out
control.
of limit.
Hmm.
So we did homogenization and we eliminate all the special classes. Then we plotted again the control chart.
Mhm.
So
I agree with you.
it's
Control
okay.
charts during the PPAP run
Okay, sir.
may not have control limits because you don't have any samples. Okay.
Okay, sir.
You have very similar process already established running successfully. You can take control limit from there.
Okay, sir.
Okay. But strictly speaking, control charts during the PPAP run initially may not have the control limits.
Okay, sir. Okay.
Then, calculate as you have done, so nicely, calculate all the control limits, just fit in and then see whether any special cause variations are there. No, normality is okay, stability is okay.
Okay, sir.
Then go for, regular studies.
Okay, sir.
What's your second
Okay.
question?
Okay, sir. So the second question is, when will these SPC studies be conducted besides the
Okay.
IPS, which is initial process study? Apart from
Initial
initial
process.
process study, is there any other
Okay,
situations?
initial process study means
Okay.
it is, I give a different version of CPK studies.
Okay, sir.
Initial process study means, just type, initial process study means CPK study, target
1.33.
special causes 1.67. That's why I said I am going to give a different version of 1.6 minimum. During PPAP run, just type that also. During PPAP run.
Yes, sir.
Since you have taken our course, meticulously, you are able to understand, faster.
Thank you. Thank you, sir. No, the concept is very clear. That's why I can able to understand.
Yeah.
The course is designed in such a way,
Yeah.
very crisp and clear. So shall we go for next question, sir? So the question number 3. Control charts monitor process stability while histograms analyze data distribution or normality. Is this statement correct, sir?
Okay, sir. Not only control charts are meant for not only process stability, but also for process controls.
Okay, sir. Okay.
You can type here.
So the question is, when should the control charts and histograms be used?
Okay.
Is there any scenario you can give with example?
Okay. You have given a set of data from the workbook, which were collected, in a sequential way.
Okay.
There you can go for a control chart study as well as histogram study.
Okay.
Whereas, please type histograms histograms, grams, or to study the process behavior, comma, especially when the behavior, especially when the data points are data. Yeah. Data points are mixed in nature. Mixed in nature. Example, within bracket, example. My organization is getting supplier parts. Organization, ORG is sufficient. Yeah. Is getting supplier parts. Parts. In this case, no control charts are applicable. Only histogram studies are applicable. Applicable, yeah. Only histogram analysis. There are many studies available, but definitely not control charts because it is a mixed lot. It will be a mixed lot.
Okay, sir.
Whereas when I have complete monitoring of my process, you can go for a control chart or histogram, capability studies, everything. But
Okay,
on the
sir.
supplier parts, you can go for capability studies also.
Okay, sir.
Okay, additional value.
Okay, sir.
Your supplier parts, you can go for capability studies also. So, I mean, once you are comfortable with the bell curve. Okay. Many questions. Good.
So, sorry, you things are disorganized.
Wow.
So, and the below image, the first image, parts are out of specification on one side here, which is
Absolutely.
going out of spec. So, with a rejection rate calculated as 1.87 percentage based on the Z scale.
Yeah.
So, we can inform to our management directly that if we continue to run the production, so we will get a 1.87 percentage rejection. That's it.
If no actions are taken on the process.
Yes, if
Because
we don't take any
widespread
corrective
is
actions on the
shifted
process.
and also little widespread. Okay,
Yes.
agreed.
So what happens if both sides goes out of spec as shown in the image too?
Yeah, yeah,
How to
absolutely. Super,
calculate?
super. You have done it so nicely. Both the sides you should add, that's all. Example,
Okay, sir.
this side, 1.9,
Okay.
right side 1.9, user side, LSL side 1.5 means add both, that's all.
Okay, sir. Okay.
They are called as total defectives.
Okay, sir. Okay. Okay, sir.
Clear?
Yes, sir.
That's all.
Yes, sir.
Good.
That's all about this question.
Excellent, excellent, Thiago. You have done a
Okay,
very
sir.
nice job. Question number 5. Oh, shoot.
So in PPK work instruction, setting and the approval of tolerance, in told that 25 percentage or 50 percentage.
25% either side for setting approval.
Either
Totally
take, so
50%.
overall 50 percentage, right?
Yeah, yeah, absolutely, absolutely.
Which means, so for example, 10 plus minus 0.5, here ESN is 10.5 and LSN is 9.5. So nominal is right,
Normally it's not 9, nah?
10, 10, 10, 10, which means
50% of,
9.75 to
yeah,
10.25. Can I say like
yeah,
that?
yeah, yeah. Just type if you want. Yeah.
10.75 to 10.25.
10.25 for initial setting approval. Is that okay?
Yes. So shall we go for next question, sir?
Wow. Mhm.
So PPK is a part of PPAP, which will be conducted at the initial process study, IPS. What about CPK? When it will perform?
Okay. That's why I said I'm going to add a different version now. Okay.
Okay.
You simply consider PPAP run is CPK. Just type that. PPAP run is equal to is CPK study. Okay, CPK study within bracket short-term study. Short-term study, because the American school of thought is slightly different from Japanese school of thought. And let's
Okay,
not
sir.
complicate much. Short-term study, 1.67 minimum target. Okay. After PPAP approval, PPK study, long run. PPK study, yeah. Study, long run. Long-term study, yeah. Long. It is not long.
This one target, sir? 1.33.
33 minimum, yeah. Because all different causes will come and then occupy in your process.
So, but generally for PPK, we will say
Yeah,
1.67 target.
that's why I said, call the long term. Correct, sir. It's not long term. Yeah.
Oh, sorry, sorry.
Yeah. So you
Thank you.
simply, understand now. You please take our next level of, SPC, that is advanced SPC.
Okay, sir.
There you can understand in a much better way. Okay.
Okay, sir.
So you
Okay.
call, short term PPAP, long term after PPAP approval, regular production.
Okay, sir.
Yeah.
Okay, sir.
Seventh one.
The seventh one is difference between process mean and a process mode.
Mhm. You could
So
see
what is
from
mean
the
by process mean
picture
and
itself.
process?
Okay. So the top, mode and mean, X double bar as well as mu,
Yes, sir.
as well as, mode. Okay.
Mode.
Both are falling in one line. That means it's a bell curve.
Okay, sir.
The bottom, you could see it is skewed distribution.
Okay, sir.
Okay. It is skewed left. Okay.
Yes.
So mode is the peak point, whereas process mean is the average of all averages.
Peak point means peak point of this distribution curve.
Distribution. Yeah. That is
Okay,
mode.
sir. Okay, sir. Okay, okay. Now I get it.
Yeah.
So the dashed line, which is a process mean, we get directly from the data which we collected from the process.
Absolutely.
Whereas this peak point we get based on this histogram,
Yeah, that is
based on
also from the
the data
process
distribution.
results. Oh, yeah. From the histogram simply.
Okay, sir. Okay. Okay, sir.
Clear?
Yes, sir.
Excellent. One more question.
So this is the last one. Oh, there is one more.
Uh, it's not last.
So,
Okay, we'll call this as last. It doesn't matter.
okay.
Okay. Stability, or sample size.
Size.
Yeah.
So
N,
3 to 6.
yeah. You can call, 5 and 25.
So, no, so as per rule is 3 to 6, right?
No, 3 to 6. I agree with
Yes.
you. 3, 4, 5, 6. Anything is fine. 3 to 6.
So subgroup size is
21 minimum.
okay.
Okay.
So for this is
7 to
7.
15. Yeah. From my memory, I'm telling 7
Yes,
to
sir.
15.
Again,
Here
for
also
this
21.
okay.
Here n is always 2.
2.
2. Minitab considers as 1 also, but we are okay with 2. Okay. Subgroup 21 minimum. P chart, okay. All P and PCU,
Okay, sir.
you must have, I could say, at least 30 data points.
Is 30 samples.
All 30, yeah. Nothing like, M.
Okay, sir.
At least 30, I agree.
Okay. So nothing like 1 means at
No,
least
no,
1,
nothing like
minimum
M.
1.
Nothing like M.
Okay,
Okay.
sir.
They are going by counts.
So I just put nil.
You can put NA, not applicable. You gathered everything all in one. Good.
Everything is for my reference.
Yeah, it's for everyone now. Yeah.
It will be very easy to refer in the
Normality
future.
histogram 50 minimum, 50, but not applicable. That can be 1 also. Normality box plot 20, sir.
So minimum, everything is a minimum 20,
Yeah.
right?
Yeah.
Which here, sir, the subgroups not applicable.
No,
This
not
one
applicable.
is okay.
This we have already discussed. Okay.
Yes, yes, sir.
Something like, PPK long run.
Okay, sir.
Generally 3 to 6. I agree with you.
PPK 3
Yeah,
to
3 to
6.
6. Yeah. Because generally it will come out of your control charts. I assume that there is a control chart present. Okay.
Okay, sir.
21 minimum.
Okay, sir.
Here predominantly, okay, Schubert recommends as 5, 3 to 6 is fine.
Hmm.
Otherwise, you may consider 5 into 25. 5 and 25.
Generally, for this CP, CPK, and PP, PPK, people used to say that minimum 30
Yeah,
samples.
yeah, 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 yeah. CPK I consider as, short term.
Okay.
Z methodology, ideally 100, sir, in my opinion.
Okay, sir.
You can consider as, not applicable.
Okay, sir.
Good.
Is
Excellent.
there anything else I need to
Yeah.
add beside it, or anything I
There are
forgot?
many, rather. Okay.
Okay.
In Six Sigma, Lean Six Sigma and all, there are many tools. This is good enough for SPC.
Yes,
Perfectly all
yes.
right.
Okay, sir.
Good.
Okay, sir.
Thank you. Thank you for your time, efforts. Very good work on, especially on,
Thank you,
control
sir. Thank you
charts,
so much.
macros. Okay. So
Thank you,
hope
sir.
it will benefit so many people in the days to come, years to come.
No problem, sir.
All the best. Let's connect again. Bye.
Thank you, sir. Thank
Thank
you
you,
so
sir.
much.
Bye, bye, bye.